There are two types of division that we're going to discuss as far as working with polynomials. The first one is the nicer one, the shorter one. The second one is the longer one. That's surprisingly called long division. The first one is for when we're dividing by just a monomial, so just a single term in the denominator. And what we can do is we can use this rule about splitting up our division problem into several smaller division problems, or what look like fractions, and basically say to ourselves then, for each one of these little fractions that we have, how much can we reduce, how much can we simplify each one in order to get our final answer. So for instance, here in the first example that's already completed, you've got the three terms up on top, you've got a monomial in the bottom, x. I'm going to take each one of those three terms and put it over top of x. And then looking at each term, we can simplify as much as possible. And you might look at it literally as a fraction and think about being able to slash things out. As far as the variable parts of these, you might look at them and say, well, I can use my rule for exponents that says take the power from the top, 3, minus the power from the bottom, 1, in order to get my power on x, power of 2. So whichever way you actually happen to like doing that yourself, fine. Once everything's simplified, each of your pieces should be part of your final answer. So let's go ahead and work out this example together, where what we've got here, longer numerator with 4 terms showing up, a little bit more going on in the denominator by having a number in there in addition to some variable stuff. So we've got a coefficient in there on the bottom. What we want to do is start out by taking this and breaking it apart. Since we've got 4 terms on the top, we're going to have 4 separate smaller fractions to deal with. We're going to take each term from the numerator and put it over top of the 3x squared. So take the second term, put it over 3x squared. Take the third term, put it over 3x squared. Take the fourth term and last term, put it over 3x squared. And then see how things play out here. What we want to do basically is look at each fraction as having 2 components. We have the number, the plain old number stuff that shows up in each of those, as well as the variable stuff. As far as the plain old number stuff, we can literally look at that as a fraction that we're used to dealing with in the past, 18 over 3. Well, I could say literally 3 goes into 18 6 times, or looking at it from more of a fraction perspective, 3 goes into 18 6 times, 3 goes into 3 1 time. I don't need the 1 on the bottom for the number part, so I can go ahead and begin that answer with the number 6. Then for the variable part, again, you're welcome to look at it in terms of your previous fraction experience and say, what can I slash out from both the top and the bottom, factors that they have in common. Or you could look at it in terms of the rules that we have for exponents, where we've got the power from the top minus the power from the bottom. That would give us an x with a power of 2. That takes care of the first fraction, so I go ahead and move on to the second fraction again, looking at it as 2 separate components. The number component, 9 over 3, would simplify to give me a 3. Using my rule for exponents, power from the top is a 2, minus power from the bottom is a 2. 2 minus 2 is 0. And remember, we had a second rule in our list that said if we've got a power of 0, that's just going to go ahead and implode and become a 1. 3 times 1 is 3. So we don't actually have to write down any more for that answer, or that part of our answer. We've got our plus sign. The number stuff reduces and gives us 3. The variable stuff ends up going away. Third fraction that we've got to deal with 27 over 3 gives us a 9. And if we look at the variable stuff and use our rule for exponents, power from the top is 1 minus the power from the bottom is a 2. That means that we would have a power of -1. And in the fourth term, we can't do anything with the numbers that appear, and because there aren't any variable pieces appearing in the numerator, we don't have anything there to work with the x squared from the bottom, so we can go ahead and leave that as it is. Now, if we're allowed to get away with an answer like this, there's certainly nothing wrong with it. However, if we had to follow that previous sort of instruction about giving an answer with only positive powers, then this third term in our answer isn't going to fly. And in that case, we would need to rewrite things according to those directions so that that third term would be a 9 over x. So again, depending on your directions, you have a little bit of leeway with what you may be allowed to write as your final answer. Now this is pretty nice and pretty short to accomplish in the grand scheme of things. And given that, let's try to use as much as we can of this very nice idea when we have to deal with longer division problems. So long division with polynomials. Again, this is best seen through an example. And since we've talked about long division with regular numbers, we'd like to use as much of that as we can get away with. And if we need to bring in this new idea of being able to divide by a monomial, then that's also something that I might find handy to use. So between the old and the new, I can actually work through the steps to take care of long division with polynomials. So this first example here, we've got a 2x squared minus 4x plus 18 being divided by x plus 3. Now, that is not a very nice looking division problem to work out, if only all of the extra stuff up on top was gone except for the 2x squared, and all of the extra stuff on the bottom was gone except for the x. That would be a really nice division problem to work out. Be really quick for us to do. That's exactly the sort of thing that we're going to do in order to actually kickstart our work. We're going to take that nastiest term from up on top, the 2x squared. We're going to divide it by the nastiest part from the denominator, the x, and get a 2x. Real nice. Now, that beginning division problem that we worked out, thinking of our regular long division process. When we kick off with the division question, the answer that we have gets put on top. So I'm going to go over, I'm going to put that 2x on top. I'm going to make sure it's lined up in the column where the other x related stuff would be going. So I'm going to line that up, put it here. Then that normal long division process continued with, when I put something on top, I multiply it by what's out front, and then do a little subtracting. So this is what we've got written off to the side. We take that 2x that we just put on top. We multiply by that polynomial that's out front. And we get what's written here in blue, the 2x squared plus 6x. Rather than saying let's subtract, because it's easy to lose track of subtracting, it's better maybe if we say let's change the signs. And let's use a different color to do that so that it stands out. I know that I changed the sign on the 2x squared. I know that I changed the sign on the plus 6x. And so now, my normal long division process would be do the subtraction work and see what little remainder you get. The x squared stuff is going to go away, so things get a little bit nicer looking. The x stuff, well, I'm going to get a negative 10x. And I haven't used the plus 18, so I'm going to go ahead and drop that down like I would in other usual long division problems. And at this point, while things are a little nicer looking, I'm still not done yet, because I can go back to that very basic division idea and make some progress. That is, the nastiest part that I'm looking at now here has a negative 10x. I put that over top of the same x that came from the original denominator. So the negative 10x divided by x gives me a negative 10. When I take that negative 10, I'm going to put it on top of my long division symbol. So that's now in this very last column. So I should be closing in on my final answer. So again, the process of long division, I take that piece that I put up on top, I multiply it by what's out in front of my long division problem, and then I have to do a little subtraction. Well, instead of subtracting, we're going to say change the signs. So the negative 10x becomes a positive 10x, the negative 30 becomes a positive 30, and go ahead and move down my columns. My x stuff goes away. My constant stuff, give me a 48. And can I do anything else? Well, if I take that 48 and try to divide by the x that I had been using, that's not going to give me anything useful. So I'm going to stop here and say, all right, I'm ready to build my answer. What I'm going to do in building my answer is use the same pieces that I have used in the past for building a mixed number answer, with one little twist. The mixed number answer started by using the quotient. The quotient is whatever is on top of my long division symbol, followed by the remainder over the original denominator. Well, my remainder is 48, my original denominator is an x plus 3. The little twist here is that mixed numbers didn't have a plus sign in between the quotient and the fraction business that uses our remainder. We are going to put in a plus sign so that things are very clear. We don't want any sort of confusion between the end of our quotient, which is the 10, and the beginning of our remainder, which is that 48. So we're putting together something that is almost like a mixed number. The quotient, plus sign, remainder over original denominator. Now again, notice that what we've got going on for our steps is basically this. We do a little division problem. A little division problem. A little division problem. Something nice, something that's manageable. So we do a little division problem as our first step. The answer needs to go on top of our long division symbol, and we take that answer and multiply it by what's out in front. So after I do a little division work, I'm going to do a little multiplying work. Then in red, we've got to do a little subtracting, and we're saying change the signs to make sure that we cover our bases. And what we get is a little remainder. So a little dividing, a little multiplying, change your signs, get a remainder. This is my cycle of steps, these 4. If I can begin and make progress with that cycle of steps, well, then I'm going to do that until I cannot make any more progress, until that last remainder cannot be worked with anymore. So those are the 4 steps that I want to do again and again and again until I can't do them anymore. If I am careful about doing that, I can complete my long division problem so that it is called long division because, yes, it's long. It is not called hard division because it doesn't have to be hard. It will have to be long, though. So let's take a look at a couple of examples to work together from scratch. And again, I want to remind you here while I'm setting everything up in this problem that the subtraction is built into the process that we're doing by saying that we're going to change the signs. So again, I'm going to use a different color to take care of that. while the other work that I do off to the side, I'm not going to use color really to emphasize that. Now, this problem has a wrinkle to it that we didn't have with our previous example. The numerator in this next example begins with a 4x power of 3 and then moves to a minus 19x and a plus 40. And there's no x squared that shows up there in that numerator. We might have x squared that shows up in the process of going through our cycle of 4 steps. So just in case we do, you have 2 options. My personal preference, put in a placeholder for any missing term from the numerator. So I have a missing x squared, I'm going to put a placeholder in plus 0x squared. That's again what I like to do. Other folks like to take advantage of the second option, which is just to leave a blank space. So if you leave a blank space in there, you're still representing and having a place that the x squared stuff can appear, and this helps you keep things neat without having any sort of issues of squishing your work together. Again, my preference is having that placeholder in there. So, on the off chance that I end up having some x squared stuff appearing as I work through my steps, I've got a place for it to go so that I can keep things nice and neat. Now, I want to actually begin working through that set of 4 steps. So what we're going to do is, again, we're going to start with the nastiest term from our numerator. And we're going to divide that by the nastiest term from our denominator. This gives us a nice basic division problem to work out and kickstarts our division process. So 4 over 2 gives me 2, and x to the power of 3 divided by x would give me x squared. Well, right away, what we're seeing is that we have some x squared stuff that shows up, and it's a good thing we've got a place for it to go, because the 2x squared I would like to put in the column where all of the other x squared stuff would end up appearing. So I'm going to put my 2x squared up here on top of my long division symbol, and this is going to be the first part of my overall answer. So 2x squared is going to be the first part of my overall answer. Continuing with my set of steps, I need to take the 2x squared and I need to multiply it by what's out in front of my long division problem. And that'll give me 4x to the power of 3 minus 2x squared. So I'm going to write that in on my next row. That's the second step of what we have to do. We did a little division problem. We got the first part of our answer. We do a little multiplying work. Now we've got to have the subtraction. That's built into our process by saying that we will change the signs. So even off to the side, I can make that comment to myself and again use a different color to help this stand out. I want to change the signs. The 4x to the power of 3 becomes a minus or negative. The minus 2x squared becomes a positive. And this will give me a little remainder of 2x squared. I've already set things up by dropping down the minus 19x and the plus 40. So we can see that we are likely to have more work to go through, but that work is going to be a repeat of those 4 steps. So we're looking at this little remainder of 2x squared. Well, let's go back to the beginning of our cycle and see if we can do a little division problem and keep going. So off to the side, we are going to do a little division problem, which will be taking that 2x squared and dividing by the 2x that we were using earlier. This will give us an x. Now when I move up on top of my long division symbol and put in that x in the column where all the other x stuff is going to go, I need something that's going to go between these, something to connect them together. This isn't a negative. That doesn't come from our division problem. So I'm going to default to a plus sign in between those two terms. So down at the bottom here, as I'm building my final answer, I'm going to have a plus x showing up next. Well, that's a little division work. Now I need to keep going through the other steps in my cycle. I need to do a little multiplication work where I take that x and multiply it by the 2x minus 1. And I'm going to write that in my next row. And then I'm ready to change signs. And after I change my signs, I'm ready to work out my little remainder. My x squared stuff will go away, as I expect it to. My x stuff, well, that'll end up giving me a minus 18 or negative 18x. Again, because I'd already mapped things out, I already have that plus 40 dropping down. And again, I've got my little remainder. I can go back to the beginning of my cycle of steps and see if I can do another little division problem and continue working. So clearly I've got it mapped out, but there's a little bit more left to go. And so we're going to be taking that negative 18x and dividing by 2x, and that'll give us a negative 9. So I'm going to go up to my long division symbol. I'm going to put in that negative 9. And that means that the next part of my answer is going to be that negative 9, or minus 9. Now that just went into that very last column up on top of my long division symbol, so I should be very close to the final work and the final answer that I need. So we did a little division, got that negative 9. Now we're going to take that negative 9, we're going to do a little multiplying. And that'll give us this negative 18x plus 9. Then the third part is to change signs. So we're going to change the minus to a plus. We're going to change the plus to a minus. And that will give us no more x. 40 minus 9 will be 31. So, just to cover our bases, our set of steps begins with a little division problem. 31 divided by that 2x, not giving me anything nice and useful, so I go ahead and I stop my division cycle of steps and say, this is my final remainder. We've already built part of our answer by including everything that's on top of our long division bar. So we've already got the quotient for our answer. In between the quotient and the rest of my work is going to be a plus sign. So a plus sign followed by the fraction part of my answer. Now the fraction part of my answer, the remainder, the final remainder, goes on top. And the denominator is the original denominator that we had in our problem. So the 2x minus 1. going to take a look at it. One more. What seems to be a little bit longer problem, but is actually pretty manageable in the grand scheme of things as it turns out. I've already set up the long division problem. In doing so, I've recognized that my numerator has skipped over the x to the power of 4 term and the x to the power of 3 term. My personal preference is putting those placeholders in there. If you prefer instead to just leave blank spaces, then you would be leaving 2 spots blank. One spot where the x to the power of 4 stuff could show up if it needs to. And another spot for where the x to the power of 3 stuff would show up if it needs to. So one way or the other, you want to make sure that you've got that squared away so that your work is not all squished together and nasty, and basically that's because I don't want to make a mistake that I could have avoided by being a little more thoughtful. As far as working things out, we want to work a little division problem, which is going to be starting by taking the nastiest part of our numerator and dividing by the nastiest part of our denominator, and that will give us a 4x to the power of 3. So I'm going to put that in the appropriate spot up on top of my long division symbol, and because I've got room, I can go ahead and put that at the beginning of my final answer. Now, rather than taking up some extra room and showing the multiplication, I'm just going to talk my way through it. I'm going to take that 4x to the power of 3. I'm going to multiply by everything out front, so 3 terms. 4x to the power of 3 times an x squared. That'll give me 4x to the power of 5. The 4x to the power of 3 on top times a minus 2x, or a negative 2x, would give me a minus or a negative 8x power of 4. And the 4x to the power of 3 on top times the positive 4, or plus 4, would give me a plus or positive 16x power of 3. My third step is to work out the changing of the signs. I like to use a different color so that I can keep track of changing all of the signs in that row. And then actually going through and doing that. 4x to the power of 5 stuff, minus 4x to the power of 5 stuff, no more x to the power of 5 stuff. 0x to the power of 4 plus 8x to the power of 4 gives me 8x to the power of 4. 0x to the power of 3 minus 16x to the power of 3 gives me a minus 16x to the power of 3. Then we've got 3 more terms that we haven't used yet. My personal preference is to carry all 3 of them down so that I keep things nearby and I'm less likely to make a silly mistake as I work through any more of my problem. Speaking of working out more of my problem, I'm now ready to go back to the beginning of my set of division steps, the beginning of my cycle that says I need to work through a nice little division problem. So I'm going to use the nastiest part of what I'm currently looking at, the 8x to the power of 4, and I'm going to divide by the same x squared that I had used originally. I get 8x squared, which means that that would automatically be considered a plus 8x squared. I move to the second step in my cycle of steps, the multiplying step. I need to take the 8x squared, multiply by all 3 terms that are out in front. That'll give me 8x to the power of 4 minus 16x to the power of 3, plus 32x squared. Now I'm ready to do the third step, which is to change the signs. So everything that I had just written down gets a change of signs. And working down the columns, x to the power of 4 stuff goes away, as I would expect. X to the power of 3 stuff will also go away, so that's a little bonus for me. And what I have showing up for my little bit of remainder stuff is just going to be a minus 10x squared. So that'll go ahead and carry down those other two terms that we still haven't used yet. And then I'll move off to the side and see if we can work out another little tiny division, which would be taking the negative 10x squared that I'm currently looking at as the nastiest stuff, dividing by the x squared that I've been using all along, and getting a negative 10. Well, that's a plain old number, so I'm going to put that in the very last column. And because there doesn't seem to be anything else to worry about after the x squared, other than writing in that minus 10, I'll just go ahead and, in my final answer, bring that in a little closer. A little bit of division. Taking the negative 10 and multiplying it by all three terms out in front gives me a negative 10x squared plus 20x minus 40. Now I want to move on to my third step, which is changing the signs, and work out my little remainder here, which is going to end up being a 3. Moving off to the side, trying to begin my cycle of steps again. 3 divided by that x squared is not giving me anything useful, so I'm going to stop with that particular remainder, consider my long division work done, and just build the rest of my answer here, which would mean that I would have my quotient already squared away. After the quotient, I'm going to put in a plus sign, and then I'm going to have a fraction that appears. The top of that fraction is going to be my final remainder, which is a 3 in this case. The denominator is going to be the original denominator that we had in our problem. And that's all she wrote. Again, long division, yes, it is long, but it does not have to be hard. Basically, we're working through many of the same kinds of steps as we've done with other long division problems. It's just that the beginning, well, most noticeably, the beginning part of our work, the little division problem that we're doing and the little bit of multiplying that we're doing, means that we have to be comfortable with that basic division with monomials. We have to be comfortable with our distributing as far as doing that multiplication step. We have to be comfortable with our adding and subtracting, so our combining like terms. So we're using a lot of these, as much as possible, the most basic elements of working with polynomials to do something that is otherwise much more complicated. So those 4 steps: little bitty division, little bitty multiplication, change your signs, get your little bitty remainder, see if there's another cycle of steps that you can do in order to continue working division until you cannot do that cycle of steps anymore, at which point you have reached your final remainder and you can build your final answer. It's long, but it'll get you there.